Hello everyone. So today we are going to understand sliding window log algorithm. So in this algorithm, it basically stores the timestamp of each request and using this information to determine whether new request should be allowed or not. So basically we will be queuing the request in this algorithm. Whenever a new request will be coming to our application server, we'll identify whether this request would be allowed or not. Now let's understand how this works. So let's say a request arrives to our application server. So first in the window, we'll try to remove the older entries. So we will maintain a queue here. We'll see in the implementation how this works. So in a queue, we will store the timestamps of the request when it arrived. So let's say here also we'll be concerned about two parameters, which is the max request allowed and like what is the window size and how many requests in that window should be allowed. So let's say if we have our window size is of 1 second and max request we are allowing is 3. So what does this mean is like when we are getting the new request, we'll check that when was the last request made to our application server. If the difference of both of the timings is greater than our window which we have defined, we will remove those first timestamps which are present in the queue. Then we'll try to count how many requests are still pending in our queue. After removal of the older request, we'll try to count how many are still pending in our queue. Let's say that count is within our limit. So what does this limit means? Like the max request which we have defined per window. So let's say if it is within the limit, we'll try to add the current request timestamp to the queue and hence the request will be allowed. Let's say if the count was exceeding the limit, like it was not less than the limit, will deny or like request would be denied. So now let's understand this using an example. So as I mentioned, here also we'll be concerned with the two parameters. One is the maximum request per window, which is 3, which we have defined here, and the window size, which is 1 second. Right, so let's understand this using the timeline diagram. So let's say time t is equals to 1 second, we got 3 requests. All of this request would be satisfied. Now, when we hit the mark of t is equals to 2 seconds, so first, this all this request will be removed from the queue because now this will be the older request for this particular timestamp, and whatever the new request is coming in will be allowed. So let's say in the time frame from t is equals to 2 seconds to t is equals to 3 seconds, we got 3 requests and additional 2 more requests. So as like in 1 second, we will only satisfy 3 requests as per our max request per window parameter. These 2 requests will be rejected. R4 and R5 will be rejected. So this is how this algorithm works. Now let's deep dive into the implementation for the same. So here I've created a class sliding window log rate limiter. So it holds two parameters, window size in second, which is the window size which we'll define, which is 1 second, and the maximum request per window. Here also we are rate limiting per user. So we'll hold the information for a particular user, like how many requests that user has made till now. So that is stored in this map. So key is the user ID. The request info holds the requests made by the user, right? Now we will initialize this parameter in the constructor of the window size in second and the max request per window, which is 3, and the window size is 1 second. Now, whenever a request is coming from a user, we'll try to check using this method allowed request if that request should be allowed or not. So we'll have a parameter user ID, and first we'll calculate the current time at which the request is hitting our application server. Now let's say this was the first request from that particular user. We'll try to initiate like a request info for that particular user. And let's say if it was not the first time the request is getting made by that user, we'll try to get its information for that particular user, like what is the request state right now. So how many requests have been made and all those stuff. So let's see first this before checking this logic. Let's see what is this request info class holding. So request info class is nothing but it is holding the request timestamp queue basically for that particular user. And let's say once the request is getting made for the first time, we'll initialize this queue. This queue is implemented using linked list. So we'll initialize that queue first. First request is made when. Now, let's say uh, what this method is checking, right? So I will first check that for this particular user when the request is getting made, being it a first time or the second time, like it's not the first request by the user, we'll first check that whether our request timestamp for that particular user, which is holding the request times at which the request was made, is not empty. If it is not empty, we'll check that whenever the new request is coming at this particular time, current time, and whatever is present in the queues, like for whenever the queues front, whatever is present, we'll check if the difference of that is greater than or equals to our window size. So let's say the difference is more than 1 second. So basically, what does this mean? That let's say a request was made at 1 second, and let's say the next request is getting made at 2 second or more than that time. So basically, it's like previous request should be removed from the queue, right? And this divided by 1000 is because this is in seconds. This value will be in millisecond. So this difference will be in the milliseconds because current time in millisecond is what we are storing. And hence I'm doing divide by 1000 to make it into seconds. And hence we will remove those requests from the request queue, request timestamp queue, and we'll pull it off. So once we are done with that operation, this is basically, I'll show you in the diagram which I was explaining. So it is this step. First, it will remove the older entries from the window. Then it will count how many are present in that particular queue. And then we will check whether it should be allowed or not allowed. So once this is done, this clock block is executed, we'll check that for that particular user, what is the size, right? How many requests are there? So let's say if it is less than the max request which we have defined. So queue size is nothing but the request it would be holding. So that we will get it from there. If it is, then we'll offer. Offer is nothing but adding into the queue. So as I mentioned that we'll be adding the timestamps of the request in the queue. So I'm adding the current time here and request will be allowed. If this is not the case, like it has already exceeded the limit, we will deny. So this function is nothing but I want to just, for the logging purpose, I want to just see what is the state of the queue. So that is just printing what elements are present in the queue. Now let's see how we are simulating this. So here the window size in second is I have set to 1. Max request per window I have set to 3. Initializing it and using the constructor and setting this both the values there. Now let's say we have simultaneous 3 requests from a particular user. Okay, and technically all these 3 requests should be allowed because our max window for windows like max request allowed would be 3. Now I'm printing the queue to see what is the state it is looking after this is executed. Then I'm introducing a delay of 1 second. So after 1 second, we are getting 5 requests from a user. So now these requests are not simultaneous requests. So every request is coming with a delay of 0 0.2 second, right? So technically 3 requests should get satisfied and 2 should get rejected because we have in a window of 1 second, we are just allowing 3 requests, but we are getting 5. Cool. So now let's simulate this. Uh, so initially simultaneous 3 requests which are coming to our application server at this time are all getting satisfied and the queue looks like this, something like this basically. Now let's say five more requests came from that user at this timestamp. Okay. So first thing is like it is after 1 second. So previous request would get out of the queue. So this three requests would be popped off from the queue because we have crossed the 1 second window. And like three requests, as I mentioned, should be allowed. So every request here, when these five requests are coming at the delay of zero point 0.2 second, right? We have introduced that delay. So first request came in at this timestamp, the second request came in at this time, and the third came in at this time. So all these three will be present in our queue. The third request, which is coming, will be denied, which is the expected, and the state of the queue looks something like this. And the subsequent two requests, as I mentioned, would be denied, and hence the state of the queue look like this. As I also said that here we are crossing the 1 second time. So all this older request will first get out of the queue, and then the newer request would be coming into our queue. So yeah, this was all about the implementation of this algorithm. Now let's see pros and cons of this algorithm. What is the pros of this algorithm? That is very accurate, and there will be no burst of request allowed at the edge of the window. So, like when we were seeing the fixed window counter algorithm, there was a chance that our window gets reset at the start of the window. And let's say if a user is sending request at the edges of the window, we might satisfy right twice the rate of the request which we have defined, right? So let's say the rate defined is three requests per window, but we would be technically satisfying six requests in less time. So that is one thing which won't be coming in this implementation. So that will be handled gracefully here. What is the con? So this can be memory intensive as it requires storing and searching through timestamp. So we are making a queue and we need to store that, and hence for let's say high volume of like APIs which are generating high volume of request, we might have this as a drawback that it would become memory intensive, right? Or because we need to maintain the queues at which we are storing the timestamps of the request. And yes, that is one of the con of this algorithm. Also, if you want to understand the point which I explained here, like no burst of request allowed at the edge of the window, you can check my fixed window counter algorithm, which I've explained. There I have clearly took this example with the timeline diagram to make clear that what is that actually mean, coming like burst of requests at the edges of the window. I'll drop a link of that in the description. You can check it out. So yeah, that's pretty much about this algorithm. I hope you liked the content. If you liked it, do like, share, and subscribe, and follow for more. See you soon in some other content. Till then, bye bye. Have a nice day and take care.